I'm going to try to record this. Hopefully it'll work. Okay. Hopefully that's going. I wanted to put this in color, but maybe not. It's okay. It's not that big of a deal. Yeah, okay. If you have it printed out, yeah, you can read it. Okay. All right. So basically, the first thing we want to talk about is just make sure that we're familiar with the place values. So starting at the decimal point, when you go to the right, you have tenths, hundredths, thousandths, and thousandths. So all those are the ones that end in THS. And then when you go from the decimal point and you go to the left, you have ones, tens, hundreds, thousands, and so on, like that. All right. So in this example, in the thousands place, we have a 1. In the hundreds place is a 0. In the tens place is a 9. The ones place is a 5. The tenths place is a 7. The hundredths place is a 2. The thousandths place is the 3. The 10,000th place is the 6. And the 100,000th place is the 8. All right, so we need to know the place values so that we can properly do rounding of numbers. All right, so to round off to a given place value, look at the next digit to the right. If it is less than 5, the given place value stays the same, and the digits to the right become 0. And if it's greater than or equal to 5, you're going to round up the given place value, and the digits to the right become 0. All right. So if we have 0.64, and we want to round that to the nearest tenth, so this is the tenths place, the 6 is the tenths place, and it's followed by a 4. So since 4 is less than 5, then that 6 is going to stay the same. So it's just going to be 0.6. All right.
If we were to put a decimal within 60, would that be?
So you're saying, can you put the 0 like put a 0 here after it?
Because it says the digit from 0, or does it just stay that way?
So you can. I mean, it's not really wrong, but so since it's after if it's after it's like on the end, then you don't really need to write it. So it's probably, I mean, like I said, you can, it's not really wrong, but it's probably considered a little bit better not to put a 0 there at the end, because you're rounding it to the nearest tenth. So you're just going to stop at the tenths place and not put anything after that.
Okay.
So like if you were rounding it to the nearest hundredth and it was like 0.60, then it would make sense to put that 0 there. And that would show that it's round to the nearest hundredth, but it's just round to the nearest tenth, so you just stop at the tenths place. Yeah. And then the other thing too is, a lot of people ask, well, do I have to put 0.6 or can I just put 0.6? Well, yeah, you can just put 0.6 and that's fine. That means the same thing, and if I was typing that in my calculator, I would probably just put 0.6 instead of 0.6. But I just always have, when I'm writing it down, I just have a habit of always putting 0.6 because it just makes it a little bit more obvious so you don't like overlook that decimal point. So it's You know, like if you just put 0.6, it might be kind of easy to just be like, oh, that's 6, and you just kind of miss the little decimal point there. So that's why I always put 0.6 instead of just 0.6. All right. And next, we want to round that to the nearest 10. Okay, so the tens place is this 3 right here. All right. So that 3 is followed by a 4, and 4 is less than 5, so that 3 is going to stay the same. And then all the stuff to the left is also going to stay the same. And then that 4 is going to turn into a 0. So you have to put the 0 there because it's to the left of the decimal point. But you don't need to put anything else after that. You just stop there. Okay. All right, and then rounding to the nearest thousandth, so tenths, hundredths, thousandths. So that 2 is in the thousandths place, and then it's followed by a 3, which is less than 5. So the 2 just stays the same, and so does everything else to the left of that. So it becomes 63.542. Okay, and then 0.57, we want to round that to the nearest tenth. So we have 5 is in the tenths place, and it's followed by a 7, which is greater than or equal to 5. So that 5 is going to round up to a 6, and it's going to be 0.6. Okay. And 2.395, and we want to round it to the nearest hundredth. So in the hundredths place, you have a 9, and it's followed by a 5. So 5 means you're going to round up. But since that's a 9, you're going to have to end up rounding the 3 up. So it's kind of like you're rounding at 39 up to 40. So it's going to end up as 2.40. So it's just like what she asked. Is like, you don't have to necessarily, I guess, but in this case, it actually makes sense to put it there because the question was asking you to round it to the nearest hundred, and so it makes sense to have that 0 in the hundredths place because that's kind of like showing that that number was rounded to the nearest hundred. So I don't know, sometimes you'll see questions on the homework where they might ask you like which one of these answers is like a better answer, like 2.4 or 2.40. You may or may not see something like that. But yeah, I mean, it means the same, it's the same number either way, but just kind of having the 0 there or not having it there shows like, did you round it to nearest 10th or did you round it to nearest 100th? So like, you know, is it like accurate to this digit or that digit kind of thing? So it's just a small, this is a minor thing, but yeah, technically it's the same number either way. Okay. Estimating. So when they say estimate on this problem here, they really mean estimate. So sure, you could just type it in your calculator, but that's not what they're looking for. They want you to actually round each number and then do it. Okay, so they would want you to do 7 plus 12 minus 9. Okay, so 7 plus 12 is 19, minus 9 gives you 10. All right, so if you give the exact answer, they're probably going to count it wrong because they want you to estimate it. All right. And then the same thing with number 6. Estimate your paycheck working 19.6 hours at $10.25 an hour. So like what you could do here is just round that to 20 hours, $10 an hour. 20 times 10 is $200. And so basically they want you to just round your numbers off to something that it's really easy to calculate without even using a calculator. All right. Okay, so it says the bar graph shows the average cost of tuition and fees at private four-year colleges. Estimate the yearly increase in tuition and fees. Write a mathematical model that estimates average cost of tuition and fees for the school year ending X years after 1999 and predict the average cost of tuition and fees in the year 2011. Okay, so first of all, estimate the yearly increase in tuition and fees. Okay, so what they want you to do here, so in this case, they're actually not really looking for you to round it off. The estimating part comes in the fact that we're basically, you know, the whole thing's kind of an estimate because you're using, you know, past information to predict future information. So no matter what you do, it's going to be an estimate. But so what they would want you to do is take the later amount, so which from 2005 minus their earliest amount they gave you from 1999, and then divide that by the number of years from 99 to 2005. Okay, so we're going to take this number up here, which is 19,307, minus this number down here, which is 14,252. I'm going to subtract those. And then we're going to divide that by the number of years. So 2005 minus 1999. And so if you have a scientific calculator, you could put it in just like that. Or if not, you can just subtract, get that answer, subtract, get that answer, and then divide them. Either way. All right, so I got $842.50. So this is a dollar amount, so I'm writing it as 0.50, like dollars and cents. All right. Okay, so that's the average yearly increase for tuition and fees. And then part B is write a mathematical model that estimates the average cost of tuition and fees for the school year ending X years after 1999. All right, so, let's see, we're a cost, so let's say C of X for cost, and it's X years after 1999. So let's start with 14,252 because that was the cost from 1999, plus you're doing an average of this amount per year. So plus 842.50 times X. right? So that's a mathematical model or a function or equation that you could use. And then part C is basically asking us to use that function to estimate the cost for 2011. So X is the number of years after 1999. So for the year 2011, X is equal to 2011 minus 1999. So that would be 12. So X is equal to 12. And we want to plug that 12 into the function. So C of 12 equals 14,252 plus 842.50 times 12. All right, and I'm just going to type that in my calculator. Well, I'm just typing in this. Oh, I see what okay. I see. You're having a hard time reading that color. Gotcha. 14,252. All right. And that equals 24,362. All right. All right, so here's a couple of practice problems for you to try out. Maybe try those on your own for a minute. So rounding that to the nearest 10. So that 0 is in the tens place, and it's followed by a 7. 7 is greater than or equal to 5, so that means you're going to round that up to a 1. So it's going to be 98,000, and then it's going to be 210. 98,210. And then to the nearest hundredth, so you have a 3 there followed by a 4, so that 3 is going to stay the same. So it's going to be negative 0.23. And then to the nearest thousandth, we got tenths, hundredths, thousandths. So there's a 4 followed by a 2. So that'll just be 0.594. And then the nearest 10,000, okay, so 10,000 would be that 0 right there. And it's followed by a 3, which is less than 5. So that 0 is just going to stay as a 0. There's going to be 48 million. And then that's going to be 700,000. So then those turn into zeros. 700,000. All right, so everything after that turns into a 0, but that pretty much only applies to the numbers that are to the left of the decimal point. Anything after the decimal point, if it's just zeros, you don't have to write it. So. All right, any questions? All right. Section 1.3 is about problem solving, so basically word problems in this section. All right, so you might see it referred to the 4-step method, which just means understand the problem, make a plan, carry out the plan, review, and check. All right, so sometimes you might need to read the problem a couple times to make sure you understand what it's asking you. All right, so, and then, checking is always important. Make sure that your answer makes some kind of sense with what the problem is actually asking you. Okay, so most word problems, for example, your answer is not going to be negative because it's asking, how many or how long or something like that. So that would be, if you got a negative answer for a word problem, that would probably be a clue that maybe something's wrong. And also the same thing, like, you might think about, well, what does it make sense for my answer to be a decimal or not? If it's saying like, how many apples do you have? Or, it's probably not going to be a decimal. Or how many people are, such and such. Well, you're probably not going to have half a person. So you would be looking for a whole number answer instead of a decimal. All right, so number 1 says it takes a word processor 30 minutes to word process and spell check 4 pages. Find how many pages she can word process and spell check in 4.5 hours. So for this, I would use a proportion. So we're looking at a certain number of pages that can be completed in a certain amount of time. All right, now they give us 2 times that are in 2 different units. So we just want to convert that to where it's the same units. It doesn't matter if you convert it to both to hours or both to minutes. It doesn't matter as long as it's the same units for both. So you can just decide which one you prefer. So I know that 30 minutes is half an hour. So I think that's what I would do, is just put the time in terms of minutes. Okay, so it takes 30 minutes to do 4 pages. Okay, and I want to make sure that I write, again, now it doesn't matter what you choose to put on top. just as long as you do it the same across the whole problem. So that's why I wanted to write it down. So 4 pages in, oh, I want to do hours, not minutes. It doesn't, I want to do hours. Because then I can say, instead of 30 minutes, I can just say 0.5 hours equals, and then how many pages? So that would be X, the unknown number of pages that she can do in 4.5 hours. All right, so 4 pages in half an hour equals X pages in 4.5 hours. All right, so that's our proportion, that's our equation that we need to solve. So to solve that, we're going to cross multiply. So that would be 0.5x equals 4 times 4.5. All right, so 4 times 4.5 is 18. 0.5x is equal to 18, and then we just need to divide both sides by 0.5. So that gives me x is equal to 36. And that was referring to 36 pages. All right, so she can do 4 pages in half an hour. So in 4.5 hours, she can do 36 pages. All right. Okay, so number 2 says the Erno Shirt Outlet Store maintains an inventory of 5 times as many shirts in regular men's sizes XL and smaller than it does in large men's sizes 2X and larger. There are 430 shirts in inventory in the store that are regular men's sizes. How many shirts are in large men's sizes are in inventory? Okay, so the thing they want to know is the number of large men's shirts. So let's define our variable and say x equals the number of large men's shirts in inventory. Okay. And then let's see. So it says that they maintain an inventory of 5 times as many shirts in regular than in the large. So you could say that 5x is equal to the number of regular men's shirts in inventory. All right, and then we also know that it tells us that there are 430 shirts in inventory that are regular. So that means 5x is equal to 430. So that is an equation that we can then solve, and we can just divide both sides by 5. Which is 86. So that's 86 large men's shirts. All right, number 3 says the scale on an Italian map states that 1 centimeter corresponds to 30 kilometers. On the map, a small Italian village is located 0.04 meters from the Mediterranean Sea. So find the actual distance. Okay, so we have the map distance versus actual distance. So this is another proportion type problem. All right, so the map distance is given in centimeters, and the actual distance is given in kilometers. Okay, and again, so the map distance is given in 2 different units, so we need to convert it to the same units, so it's probably easier to convert into centimeters. So we're going to go more in depth on, you know, units of measurement and meters and centimeters and all that stuff starting next class. But I can go ahead and let you know that there's 100 centimeters in a meter. So 0.04, if you multiply that times 100, that equals 4. So 0.04 meters equals 4 centimeters. Okay, so that's the same thing as 4 centimeters. All right, so we know that 1 centimeter goes with 30 kilometers. So 4 centimeters goes with X. And that's what we want to find out. So just cross multiply. So 1 times X is just X. And then 30 times 4 would be 120. So that's 120 kilometers. Okay, so on the map, it's shown, you can measure that it's 4 centimeters away from the sea, which means in reality, it's 120 kilometers away from the sea. All right. Number 4 says, Joseph just changed his cable television plan to include on-demand movies for $2.95 each. The charge for the basic cable package is $24.95 per month. If his bill 1 month was $39.70, how many on-demand movies did he watch? Okay, so his bill is equal to $24.95 plus $2.95 times the number of movies that he gets. So that's X. So X is the number of movies. Okay, and then they tell you that his total bill is $39.70. So $39.70 equals $24.95 plus $2.95X. And then we just need to solve that for X. So I'm going to subtract $24.95 from both sides. So $39.70 minus $24.95 is $14.75. So $14.75 equals $2.95X. And then I would just need to divide both sides by $2.95. That's 5. So 5 movies. Number 5, I like this problem. It's a good real application like that I would use in my real life. And it's about pie, so that who doesn't like pie? Says Nella's recipe for shoe fly pie contains 3/4 cup of molasses. This recipe makes a small pie that serves 8 people. If she makes a larger pie that serves 12 people, how many ounces of molasses will she need for the larger pie? All right, and that's helpful because when you buy stuff at the store, usually it'll tell you that, how many ounces it is. So you have to know, how many, if you know how many cups, you have to know how to convert that and everything. So this is also going to be a proportion type problem. So basically we're comparing the amount of molasses with the number of people. Okay. And again, we just need to figure out. So they want to know how many ounces. So let's make the molasses converted to ounces instead of cups. So there's 8 ounces in a cup. So 3/4 of a cup multiplied by 8. So you can multiply this on your calculator actually, but it's not that hard to do by hand. You can actually put fractions in here on your calculator. So to put a fraction in the calculator, use this ABC button as your fraction bar. So put 3 ABC 4. That's 3/4. And then we can put times 8 equals 6. So 3/4 of a cup is equal to 6 ounces. So 6 ounces is for 8 people equals X ounces for 12 people. So cross multiply, so 8 times X, so that's 8X. And then 6 times 12 would be 72. So 8X equals 72. And then divide both sides by 8, so X is equal to 9. So 9 ounces. So that means the 8-ounce bottle that you probably see at the store is not quite. Okay. Number 6. The Anderson Company produces a product for which the variable cost per unit is $6 and the fixed cost is $80,000. Each unit has a selling price of $10. Determine the number of units that must be sold for the company to earn a profit of $60,000. Okay, so you have the variable cost and the fixed cost. So the fixed cost would be, this is the cost for just keeping the factory open, paying the light bill, paying the CEO, advertising, those kind of things, fixed cost. And then the variable cost is like the cost for each individual unit. So that would be like the cost of the actual materials to make the product, and maybe the actual labor to make the product. So let's see. All right, so the cost is equal to 80,000 plus 6x. So 80,000 fixed plus $6 for each unit. And then each unit has a selling price of $10. So the revenue, so the money they will actually receive, will be 10 times the number of units sold, so 10x. And then profit is equal to revenue minus cost. So profit is equal to 10x minus parentheses 80,000 plus 6x. You want to put that in parentheses to make sure you're subtracting the whole thing. And they want the profit to be 60,000. So let's say 60,000 equals 10x, and let's distribute that negative. So 10x minus 80,000 minus 6x. And we just need to solve for x. So we can combine like terms. So 10x minus 6x is 4x. So we've got 60,000 equals 4x minus 80,000. And then we can add 80,000 to both sides. That gives you 140,000 equals 4x. And then you can just divide both sides by 4. And that's 35,000. So that's 35,000 units of the product that they need to produce and sell to make a profit of $60,000. All right. Number 7 says, suppose a new house is worth $110,000 and appreciates uniformly each year. So that means that its value increases by the same amount each year. All right. So that is something that happens in real life, maybe not uniformly, but houses do increase in their value each year. So 12 years after it's built, it's worth $148,400. So how much was it worth 2 years after being built and 20 years after being built? So we need to figure out what is that amount that it's increasing in value each year. So let's take 148,400 minus the original value of 110,000. So we would subtract those and then we would just divide by 12. And that will give us the amount it's increasing each year. That's 3,200. So it's increasing by $3,200 each year. So how much was it worth 2 years after being built or 20 years after being built? So let's write down a model or an equation, like a function like we did before for the value. So the value, let's call it V of x, equals 110,000 plus 3,200x. So x is the number of years after it's built. So if we want to find out how much it's worth 2 years after being built, we're just going to plug a 2 in for that x. So 110,000 plus 3,200 times 2. And that equals $116,400. So after 2 years, it would be worth that amount. And let's see, after 20. So just plug 20 in for x. So that's $174,000 after 20 years. Number 8, Jen makes a playlist of 5 of her favorite songs for studying to. If she puts it on shuffle, in how many different possible orders could the songs be played? Assume that each song will be played exactly one time. So you have 5 songs, so there's 5 possibilities for what the first song played is. And then if each song is only going to play once, then that means then for the next song, there's only 4 possibilities. And for the next song, there's only 3 possibilities. And then for the next song, there's only 2 possibilities. And then you get down to the last song, that's only 1. So 5 times 4 times 3 times 2 times 1 is the number of possible orders they could be played in. That's 120. All right, any questions about any of that? Any questions about anything? All right, that'll be all for today. I'll see y'all Thursday. Mhm.
So yeah.
Yes, you have homework that'll be due before class on Tuesday, so I would recommend starting it as soon as possible.